All right. Good evening, everybody. Um, I hope I hope our audio is okay. Can you all hear me? Good
Yes, we can hear you.
evening.
Good
Okay,
evening. Yes, we can
awesome.
hear you.
Um, okay. So
So
while
we can
we
hear you,
wait
Immaculate.
for every o- okay, thank you. So while we wait for every other person to join us, we just have to start so we can work with time and finish on time because I know we have other things we want to do. Welcome to our food safety management training. This is being hosted by Food Mestro in collaboration with the Nigerian Institute of Food Science and Technology. And today we are here to have a training on HACCP. As we can see, that is already showing on our screen, Mastering HACCP, which is more like the level 1 HACCP. And here, our faculty, who is already waiting for us, she will run us through the introduction, the principles, understanding food safety hazards, how to develop HSCC plan, and I promise it's going to be an interesting. Usually, are kind of being it's kind of being structured in such a way that it should be interactive. So please, we should have questions. The faculty will have questions for us, and whenever you want to ask any question, you want to answer any question, let's do well to use the raise up icon so that we can maintain orderliness. So once you enter the room, just mute yourself to avoid noise and disturbance because we are all here to learn. And at the end of this training, a certificate of completion, of course, will be shared to us. Just a quick introduction of who the hosts are. Like I mentioned, the training is being hosted by Food Mestro, which is a food tech business that focuses on providing food safety consultancy and food safety trainings. And this is to help to make sure that we are all compliant to safety standards. And on the other hand, our co-host also, who is Nigerian Institute of Food Science and Technology, is a body in Nigeria representing food professionals drawn from the academia, industry, government, and research institutes. So altogether, we are here to bring you programs to equip you with up-to-date knowledge and practical skills in food safety. And this is to ensure that you stay current with global standards and best practices. Without wasting much of our time, we have our faculty. So before I introduce our faculty, I kind of want to make a request because I understand that most of us are entering the call without our names. Our names do not appear on on your Zoom account, and that will not allow us to know who is in participation, is in attendance of this training. So please, if you can help us, just label your name on your account. You understand? Just the name you use in registering. We'll appreciate that. So without wasting any of our time, I'd like to introduce our faculty, who is no other person than Onwuna Tuchinwendu Fortunate. Fortunate is a food scientist and technologist and also a professional member of NIFT. She's a seasoned food safety management system expert with over 4 years of experience in the food manufacturing industry. From leading successful FSSC 22000, AIB, and Halal audits to implementing robust food safety programs that enhances food safety culture in her organization. Fortunate has rapidly grown into a recognized industry expert. Her influence extends beyond her role as a food safety management audit and document controller at PZ Wilma Limited, as she actively shapes conversations on food safety, earning recognition as a top food manufacturing voice on LinkedIn. Beyond LinkedIn, Fortunate has made a tangible impact by training professionals, driving compliance, and fostering a culture of excellence in food safety management. Now, as a faculty member, she is committed to equipping students and early career professionals with practical insights, ensuring the next generation is prepared to uphold the highest food safety standards. Madam Fortunate, you are welcome to be in our faculty for today's training. We are delighted to have you. floor is yours.
Hi, good evening, everybody. Good
Good
evening once
evening.
again. Welcome to today's food safety management training on mastering HACCP. So today's training will be centered on HACCP, that big word in the food industry. Food business operators, we have food safety professionals, we have academians, and we have also quality assurance and quality control officers in our midst. And more importantly, we also have food safety enthusiasts. So I'm sure we have these categories of persons in this training today. So I welcome you all. Okay, just like Madam Immaculate has said, it's going to be an interactive section for all of us. Okay, I always love my class to be interactive, where you ask questions or make contributions, where and we can also learn from you. So without wasting much of your time, she had done the introduction. Like you all know, I am unattached unfortunate. I am a food scientist and technologist from Abia State University, class 2013. And I've been in the food industry for over 4 years now. Okay, I happen to be in the role of a food safety and quality audit and document controller. So everything that happens with food safety management system implementation sits on my desk. Okay, and I also want to share with us that I specialize in manufacturing of palm oil, soybean oil, and margarine, which is BZ Wima's products. So for us today, we'll be talking about HACCP. Okay, don't worry, the class we had to keep postponing the class probably to accommodate you. I just registered yesterday or so. Okay, so the class, and like I said, HACCP is that I would like to call it a buzz term in food safety. Like you can't do any other thing in food safety without HACCP. It's just the basic that you have to know for you to make sure that you understand the nature of food you're producing and as well the process environment. So at the end of this class today, we'll be going home with a lot of new things, I believe, like understanding what food safety is and what food is also according to ISO 22018 and according to Codex. Because I shared a material with us, Codex, okay, which is a general principle of food hygiene, and as well FSS 22000 decision tree. I hope we all got those materials. Did we get the materials? Can anybody say something? Did we get the materials?
Yes, we did.
Any response?
Yes, yes.
Okay. So, silence is what? Consent. So we got the materials. I know it came.
No, they said they responded. They said they got the material.
Okay, that's fine. That's fine. So the material is yours. I mean, you couldn't have gone through the materials like yesterday and today. No, but it's just for your kids. You can always read up the material after this class to understand fully what we learned. Not the definition of food and food safety, HACCP definition and its importance in food safety management, and the history of HACCP and the problem. We have to describe the key food safety hazards, the physical, the biological, the chemical, and then understanding the 12 steps of HACCP study. When you understand the 12 steps of HACCP study, you can also understand the 7 principles that are embedded in the 12 steps of HACCP study. And then at the end of this class, I expect us to be able to differentiate between a CCP, critical control point, a PRP, prerequisite program, and then OPRP in real-world examples. And then you recognize the role of documentation and record keeping in maintaining HACCP compliance, because in food safety, if it's not documented, it's not what's done. And then you have to understand the roles and responsibilities of your HACCP team members and appreciate the importance of GMPs and prerequisite programs as the foundation for HACCP. Okay, so what is food? According to ISO 22000, food is any substance. It could be your ingredients, it could be your processing head. It could be your raw materials, whether processed, semi-processed, or raw, which is intended for consumption and includes drink, chewing gum, and any substance which has been used in the manufacture, preparation, or treatment of food, but does not include cosmetics or tobacco or substances ingredients used only as drugs. So in this context, the context of ISO 22 food, things that such as ingredients, such as your processing aids, your raw materials, and then the even as water as part of your food is also a food. And then you do not call cosmetics or tobacco or substances used only as drugs. They are not food. So this definition is from ISO 2018. And then what is food safety? Food safety is that assurance that food will not cause harm or adverse health effects to the consumers when it is prepared or eaten according to its intended use. So basically, you hear a lot of definition about food safety. Food, some persons say is the practices that to make sure that the food is safe for consumption. But for those of us that are into implementation of food safety management system, this definition best describes what food safety is all about for us. So it's that assurance that when your consumer takes your products, it doesn't cause any adverse health effects. It could be injury, okay, or death to the consumer when the food is prepared or eaten according to its intended use. So the food suitability is also part of the food safety, because most times when I talk about food safety, I always want to bring the aspect of suitability of the food. The assurance that food is acceptable for human consumption according to its intended use. And so what is HACCP? Like I told us today, our class is all about understanding hazards in your process, in your products, and then putting controls to make sure that these hazards, they do not cause harm to your consumer. So the formal definition of HACCP is what? The systematic science-based approach for the identification, evaluation, and control of food safety hazards from raw material to consumption. From raw materials to what's the consumption, even everything that enters your food during process, the approach of identification of the hazard associated with them and evaluating them, and then putting a control so that it doesn't cause harm. It is more like you are anticipating a hazard, that this might happen, this will happen if you do not control it. And then it goes beyond just identifying hazard. Most times you say, oh, this is hazardous, and then you leave it at that. You have to go ahead to do what? You evaluate it. You have to evaluate the hazard. What is the probability of this hazard occurring, and what could be the severity, if not controlled? So that is the definition of HACCP. So HACCP has come to stay. It is an internationally recognized system used to identify and control food safety hazards. So internationally, nations, United Nations, every country, well, if not all the countries in the world now, has recognized what HACCP. So it's a both preventive and reactive approach. So most times I tell my class that HACCP could be a reactive approach as well. They look at me and say, Madam Fortunate, how do you mean? So in the course of this class, you also understand that it will also be a reactive approach. But first and foremost, HACCP is what? Preventive approach. You anticipate an issue, that is anticipate a hazard and its tendency to cause harm, and then you evaluate and control. So it's designed to stop hazards before they occur, but it also responds decisively when things go off track. That is why I say it can be what? Reactive. So they can respond to things when they go off track. During process, your food is not safe. You've identified the risk, and what do you do to make sure that that food doesn't go to the consumer? That way, we say it could be what? Reactive at that point. Okay, so the origin of HACCP, it started from somewhere, right? It didn't just appear in the news. Something happened that led to what? HACCP study. So HACCP was developed by NASA and Pillsbury for food safety in space. So at the NASA, the National Aeronautics Space Administrators. So in space, HACCP was originated in 1960 and introduced by NASA and Pillsbury Company in the USA. So what happened is that the space travelers working in the space, okay, they were having food being supplied to them by this company, Pillsbury, in the USA. And for a part of being proactive, maybe the anticipation of something might go wrong, preventive. You can imagine there are no hospitals in the space, okay, where the space travelers, they might take food that is unsafe. And what could happen if the food gets to them? So it's more like a preventive approach. Oh, the US government, NASA and US Army, Pillsbury, they collaborated to ensure that there's what we call HACCP, to make sure that food is safe for the space travelers. So this, what actually led to this, that they didn't want to rely on end product testing. You know, most times after production, each batch you test your products, yes, with a random test, and then for the space travelers, you won't want to start the random test, okay, alone, because at the same time you might not capture all the products at that time, and then people will go ahead to consume the food. I mean, the space travelers, and what would happen if the food is unsafe? A proactive measure was proposed by the NASA, US Army, and Pillsbury to make sure that they implement a kind of study to make for the food to be safe during production, I mean on Earth, before supplying to the NASA in space. So NASA didn't want to rely only on end product testing in space. So they wanted something, kind of assurance. Remember what we said is all about? The assurance that food will not cause harm to the consumer when it is eaten or prepared according to its intended use. So they wanted that assurance, a preventive measure that this food will not cause harm. And for most times, our end product testing takes a lot of time. Your microbial analysis could take up to like 5 days. So there was no time for all those. There was no luxury of time in space to maybe wait for 5 days before you start consuming your food. Okay, so this the approach of doing a study or putting controls in place to make sure that the food is safe started. So in 1970, NASA, Pillsbury, and US Army laboratories worked together to produce safe food for the astronauts in space. No astronauts got foodborne illness. Hey. So I want to let us know that no astronauts got foodborne illness in space. You know, most times when we teach this HACCP, you see a lot of persons they come up with there was foodborne illness in space that led to the study of HACCP. No, nothing like that happened. It's just that NASA, Pillsbury, and US Army, they wanted a preventive approach to make sure that there are not going to be any chances of unsafe food getting to the space travelers. So on Earth, something happened around 1971. Last fragments were found in Pillsbury's Farina baby cereal. So the Pillsbury, a company, like I told you, on Earth, not in space, the Farina baby cereal had what, a massive recall. What was found in the baby cereal was what, glass fragments, which we could classify as a physical hazard. Don't worry, in the course of the class, we understand better. So it led to a recall. For those of us in the manufacturing, you know what recall means. No food business will want to experience what recall. So I wonder what would have happened with Pillsbury when that recall happened. Lots of employment here. People will lose their jobs. It's one of the consequences of this. They will also face legal mitigations. Okay, and they will also, at the end of the day, lose a lot of money. A lot of money will go down the drain. So it was a public health concern, and most importantly, the lives of the consumers. I mean, the babies that took that Farina baby cereal they are at risk. So Pillsbury sat back again. They realized that their commercial plants, they are not using HACCP. Remember, they had developed for the space astronauts, but they didn't bring it back home, maybe to reflect in what they are doing, commercial purposes. So at that point, the challenge was that the end product testing alone failed to protect the consumers, failed to protect the babies that consumed Farina baby cereal. So we can't complete the HACCP origin without mentioning the father of HACCP. The father of HACCP is Dr. Berman. He was a microbiologist and a food scientist, and he was a chief scientist at Pillsbury. And because of his success with HACCP, a panel discussion was held in 1971 at the National Conference on Food Protection. So the first class was named Food Safety Through Hazard Analysis and Principal Control Points. So I learned that in that class, there are about three steps alone. So the furtherance of the class again and further research, it landed us at what 7 principles, no longer 3 principles of HACCP implementation. So HACCP has come to stay. There's a global relevance of HACCP. Like I told us in the introduction, it's an internationally recognized scheme for every food safety industry, for every food industry that wants to gain global relevance. I mean, HACCP is a requirement. It's mandatory that you implement HACCP to make sure that the food is safe. So HACCP is not just a company's tool; it's a globally recognized food safety system adopted by international and national bodies. So you have the codex here, Food and Agriculture Organization with the World Health Organization. And you also have FSS 22000, which is a GFSI program, Global Food Safety Initiative. So for you to gain global relevance or FSS 22000 certified, you should also have a HACCP implemented in your food businesses. So for FDA, US Food and Drug Administration, EU regulations, even for NAFDAC, here for regulatory bodies in Nigeria, SSOM, HACCP is mandatory. It's mandatory that you develop a HACCP. That way, you are able to show to the regulatory bodies that you have identified hazards peculiar to your food products and your process, and then you've also evaluated them and then put control measures to either eliminate the hazards or reduce them to an acceptable level. So it's not optional. HACCP is not optional for serious food businesses. You already know why. If you are serious, if you want to go into real trading, I mean into exportation, HACCP is not optional. It's something that is mandatory. So why HACCP matters? Why does HACCP matter? HACCP matters because it prevents foodborne illnesses and recalls. So it matters a lot that if we are able to do the right thing, if we are able to do a HACCP study in a very careful way, it prevents food illnesses and recalls. Okay, and it also ensures. Remember that if Pillsbury had implemented HACCP in their commercial business, I mean the Farina baby school couldn't have had the metal fragments in them. So it prevents food illnesses and food recalls. So HACCP also ensures compliance with food safety regulations. I used to tell my class that if we do not have food safety regulatory bodies, you will quite believe what would be happening, especially for our country, Nigeria. So for HACCP also, it matters as well because it helps food businesses comply with food safety regulations, that of the NAFDAC, the SON. And it also improves operational efficiency of your operations. It improves it. You don't need to start reworking. You don't need to start losing a lot because you are producing. It helps in maximization of profit and minimizing costs. And also it builds customer trust and brand protection. So when the people know your brand, they say, "Oh, this brand has been around for many years." So the trust is there. And there is brand protection. But it also facilitates international trade. Like those companies that are exporting, it facilitates international trade. That means that if you are exporting to countries such as US, and you have a fully implemented HACCP, it can facilitate trade for you. So start shower. Before we continue, I will also want to, what is the biggest hazard or risk that keeps you up at night about your process? So I used to really ask this question. Most times, you see me when I get home, I even have nightmares when I spot hazards in my facility. Yeah, it's the passion. what is that biggest hazard? Because right now, I know most of us, we have a lot of things running through our mind, one hazard or the other, or risk that is in your process, which you've not addressed. So if you have hazard that is in your mind right now while we are talking, or there's a risk you foresee in your process, after this class, you have to go back, review your HACCP plan, or even if you don't have any HACCP plan at all, you can always start up something by implementation of HACCP. I mean, you can make a case for your food business. You present this to the management on the need to develop HACCP. So what's one point in the process where a mistake could be deadly? Remember, NASA didn't just put humans on the moon. They helped revolutionize food safety by challenging Pillsbury to create food that was 100% safe, which led to the development of the HACCP system. So NASA, they taught us something, okay? They didn't just go there. They didn't just put humans there. So because most times when we talk about food safety, we look at it according to ISO 22018, you have to develop a risk-based thinking. Risk-based thinking, to look at your process, as beautiful as your plant may be looking, okay, look beyond what you see. You have to think, pay attention to details. So NASA, they had this risk-based thinking, and that was what challenged them by collaborating with Pillsbury to create food that is 100%. So I expect us at the end of this class today to challenge our food processes, okay? Have a risk-based thinking. Think about it. Think about the risk associated with your food process, and then implement, and then evaluate the hazards, and then implement control to either eliminate such hazards or reduce them to an acceptable level. Okay. So what is food hazard? A food hazard is a biological, chemical, allergenic, or physical agent, or a condition or circumstance of a food that, when not controlled, has a potential to cause harm. It has potential to cause illness. It has a potential to cause adverse health effects to the person who is eating it. So if you do not control a hazard, if you do not eliminate it for some, if you do not reduce them to an acceptable level, they have every tendency to cause harm. So when we talk about hazard, we see anything in the broader aspect, anything that has the potential to cause harm. So for food, we are looking at the biological, the chemical, and the physical agents inside the food. So we have the physical, we have the glass, metal, hair, plastic fragments, and then we have for biological, we have your bacteria, your viruses, parasites, example, your salmonella, Clostridium botulinum, E. coli, and so on and so forth. So they are the biological contaminants, or what you call biological hazards in food. And for chemical, you have your cleaning agent, the pesticides. And here you see I had to bring out allergenic. So some persons, we could also classify allergens as chemical hazards, or you can also classify radioactive agents as chemical hazards. So it's up to you on how you want to evaluate it, in your HACCP plan. So how do we prevent food safety hazard? Look at the picture. A food scientist is wondering, like I told us, you have to have a risk-based thinking on how you prevent food safety hazards. You already know we have the physical ones, who could be your nails, the biological ones, the viruses, the parasites. Okay, how do we prevent these food safety hazards? So for us to prevent food safety hazards, we need to understand these terms, these basic terms. So for most of us, we have this knowledge of good manufacturing practices, GMP. And so that's just about it for every manufacturing industry. So GMP is more like a prerequisite program for food safety. It's a system that ensures that products are produced consistently and controlled according to an established standard. Example of established food standards is your ISO 22018, your FSS 2000, your HACCP. Okay, they are already established standards. And so it's GMP that will set the tone, that will set the condition, the operational condition for your HACCP to thrive. So before you have a HACCP system in place, you are expected to have a good manufacturing practices. That's a system in place to make sure that it thrives. And so for GMP, we already know the 5 Ps, the personnel, the products, the procedure, your premises. So once you get these things right, once you incorporate the good manufacturing practices across this piece, okay, you are sure that your HACCP can thrive. Yeah, like I always tell my class, the first B, which is personal, you and I, the all other things so lies in your hands for success. So PRPs are part of GMPs. PR prerequisite programs, they are what part of GMPs, and they lay the foundation for HACCP. An example of your PRP could be your pest control, could be cleaning, could be allergen management. So HACCP only focuses on identifying and controlling specific food safety hazards. Okay, but that does not mean that because you're going to do HACCP, you have your prerequisite program separately. No, it's going well. Let me not be fast. The course of the class we understand better. So think of GMPs and PRPs as the walls, and HACCP as a lock on the ground. So what you need to do, what I need to do as a food safety professional, as a food safety enthusiast, okay, as a food business operator, as a food scientist and technology, what do you have to do once you have identified this hazard? So we have the 12 steps of HACCP. 12 steps of HACCP. We have the first one, which is assemble your HACCP team, describe the product, identify its intended use, construct process flow diagram, on-site confirmation of flow diagram, and then go down to step 6 to 12, and that's where you get the 7 principles of HACCP. So the 7 principles started from what? Step 6, which is conduct hazard analysis, determine critical control points, establish critical limits, monitor each CCP, establish corrective actions, verification procedures, record keeping, and documentation. So for you to even start your HACCP or your HACCP plan properly, you are expected to start with the 5 steps, the preliminary steps. So let's go further to understand better. So, the 12 steps that I have mentioned already is the first one is for you to assemble a HACCP team. Okay, so HACCP, for you to even start the study, you should have a HACCP team with the management approval. Because, like I said, it's not like you're going back to your factory alone to do the HACCP. No, HACCP doesn't work that way. Okay, HACCP comprises of multidisciplinary team members. Okay, we also have the engineers, we have the production personnel, we also have the people from the QA/QC. They form part of the HACCP. Okay, and for you to constitute this team, in your food industry, you should also have the approval from the top management. The approval has to also be documented. If it is not documented, it is not done. You define the right qualifications. Like I said, you're not going to get someone from the high school to run the HACCP for you, right? At least the person should also have the basic knowledge, maybe probably a BSc, your HND, programs, okay, that will qualify the person to be part of your HACCP. You understand me now? So you can pick people from your process, okay, from your engineering team, from your production team, or from your HR, from your procurement, from the warehousing. So you get people across things, okay, to form this HACCP team. And expertise is also required. So most times you see people present HACCP members team, okay, with signed off signatures, and then the expertise is not stated there. One thing is, you have the right qualification. So what is the expertise? What is the knowledge you have to conduct the HACCP? So what part of your expertise is this training you're doing now, and if you understand, and the certification trainings. All right. So a lot of programs are out there, trainings are out there. So for your HACCP team to thrive, you have to get them trained. I mean, the knowledge should be transferred according to Clause 7 of ISO 22000. You support your staff, okay, with the required competence for them to carry out the job of in your food safety management system. So one thing is designating roles, and that thing is also people knowing their responsibilities. So if people don't have the right expertise, okay, to carry out their tasks, I mean, the HACCP team is not adequate. I mean to say that. So after this team, depending on the size of your food industry, okay, for small food businesses can also start up with probably 10 persons. Like I said, you pick from different processes, okay, you pick from different processes, and you also pick, especially if you have R&D, yes, R&D managers or personnel in your new product development, they are critical when it comes to HACCP. You bring them to your team. So when you bring your team together, of course, with the right expertise, you define the responsibilities and authorities. So usually we assign a team leader. It's always a team leader. For us here, we have our food safety team leader, okay, and then the members, like I said, the members will be scattered across all other departments. So for them to know their responsibilities and the authorities. And once this team is being constituted, okay, of course, with management approval, it has to be dated, and it also has to be signed and documented, and also was maintained. So the roles of the team leader could be coordinating and managing the work of the HACCP team. Okay, they also ensure relevant trainings and competencies for the HACCP team. Okay, also from time to time you do refresher training. It's also part of the team leaders, HACCP team leaders job. Okay, also you can also engage food safety consultants or trainers, just like someone like me, to also train your team. Okay, what they are expected to know concerning your HACCP. So the role again is also to ensure the management and evaluate the effectiveness of the HACCP system, to know, to manage it, to maintain the HACCP system, and to also always evaluate it. Okay, the effectiveness could be through verification programs. And in the course of the class, we understand what verification is all about in HACCP systems. So the roles of the team members could be to describe the product, identifying the intended use. The engineers will always tell us, okay, at this point, we need maintenance. This is the frequency. If you don't do this, we lose it here and right. So it's not what people from the QA, QC alone can do. Okay, so we know most times when we see HACCP team members, it's always from QA, QC, QA, QC, QA, QC. But then it is not what HACCP team should be. So team members also are required to prepare and verify the flow diagrams, hazard analysis worksheets based on risk assessments, and to determine the OPRPs, CCPs, PRPs, and their control plan. Okay, so that's about the first step. The second step is after you have assembled your HACCP team, like I told you, also have it documented. You also need to describe the program. Oh, sorry, describe the product. To get a clear description of the food products, like I said, the raw materials and the ingredients, the composition and characteristics of the products, including the raw materials, the product contact materials, and ingredients, should be understood. I mean, your raw materials, okay, for instance, in my process here, you have a raw materials, and at the end of the day, we also have ingredients. It's going to come into the food, like, okay, fortification into the food. Can you hear me? A fortification into the raw materials, okay, it could be the products contact materials, your processing aids. For us here, we use Niagara bleaching it to make sure that we bleach our products. So we are expected to understand the composition and the characteristics of these products. Okay, you understanding the composition, you have to describe the physical, the chemical, and the biological composition of these products, and also understand the origin of the products, where they are coming, their handling, the product specification, how are they going to be delivered to you, how type. Is it going to be in plastic bottles? Is it going to be in cartons? You also need to understand the shelf life of these product contact materials and the raw materials. You need to know the shelf life, understand the shelf life, because most times we buy our sugar that we use for our production, okay, your salt. You need to understand these products as well from their manufacturers. And then the storage conditions. How are you going to be storing them? Example, is it frozen, ambient, method of distribution and delivery, potential for improper use or handling, product name and similar identification, general product description with brief process, labeling information, sensitive consumer information, acceptance criteria to what food was safety. So you are going to describe your food products. You describe your food products and the way it's going to come. Because you take into account the raw materials and the ingredients already inside your products. You have to describe them as well in your HACCP plan. So you are going to have a HACCP plan where you also, the first one, like I said, is to assemble your team. I always tell people it's better you do it in a sheet, an Excel sheet where you build sheets and sheets and sheets. So your first sheet could be your HACCP team, okay, where you have listed your names, the names of the HACCP team members and their roles and expertise and the dates of the study and have them signed up. Then the second step, which is describing of your products, you describe your products. You need to describe the products, the storage condition of your products, the ingredients in your products. I can give you an example of my own food industry here. The ingredients we use. Okay, you go ahead to describe them. And so most of us here we use sugar. I said you use your salt, you use your potassium sulfate and the likes. So you need to describe everything. It should be on your HACCP plan. Remember, the essence of doing these things is to identify where there is a hazard could occur, and then what you put control measures. And then your products, the finished products, you need to describe the method of distribution and delivery, the packaging type. Are you going to pack with a plastic bottle? Are you going to pack with a carton? You have to describe these plastic bottles. They are physical, they are chemical, they are biological components. You need to describe them, okay, in your HACCP plan. And then the potential for improper use or understanding, the product name or similar identification, general product description with brief process history. You need to give a brief process history, labeling information, sensitive consumer information, acceptance criteria related to food safety. Could be acceptance criteria, could be the criteria laid down by your regulatory bodies. Okay, this is the level, tolerance level of this hazard in your food and the like. So it has to be described. That should be your second step to developing a HACCP plan. So the third one is identify intended use. Here, we take into account the consumers, okay, especially the vulnerable groups. Okay, you should understand your consumer. Here are your interested parties. There's one going to consume this product, and you identify how your products could be used so it will not cause harm to the consumer. Remember the definition of the food safety. When food is prepared or used according to its intended use. When the food is prepared or eaten according to its intended use. So you need to identify the intended use. Oh, the Pillsbury company, they produce the Farina baby cereal for infants, maybe from 6 months to 12 months. You have to identify your intended use. Is it people that are glucose intolerance or lactose intolerance group of persons? You need to also identify them. You need to identify them and also put out this information in your HACCP plan. The questions to guide you will it be cooked or eaten raw? That, like I said, you have to describe this. Is your product, is it going to be cooked or eaten raw? Like my product now is vegetable oil. Okay, it could also be taken raw, and it could also be cooked. Either ways, you need to understand this. You need to identify it so that the general public or the vulnerable group will not be harmed when they are trying to consume your food, or they won't have any adverse health effect trying to consume your food. Tips could be additional preparation method before consumption. So those days when I was having my babies, you see infant formula, they describe the steps on how you can prepare this baby food and the serving conditions, how about this temperature, do not let out for more than 2 hours and the likes. Those are the things that you will need to identify. You have to identify it, and most times it always comes on our food labels. So that is the thoughts there for HACCP implementation. And then the fourth step is you develop a flow diagram. A flow diagram. For those of us that study food science and technology, you hear about flow diagram, the schematic overview of operation. It could be this way, okay. It could be horizontal, it could be vertical, okay. But what flow diagram shows is the sequential interaction of steps in your process flow. Okay, it shows the logical interaction of steps in your process flow. Or from start, okay, your raw material receipts. After your raw material receipts, your storage. Okay, at what temperature are you going to store your food? Where are you going to store? Your flow diagram should be able to outline these things and show even an external person, like it can show an auditor, oh, this is what the process. It can give an overview of what your process is all about. Make it simple. Don't cluster it. And a tip to help you as well is to also what? Number them. Let there be numbering. Because if you do not number your steps in your flow diagram, you're going to miss it all when you're having your hazard analysis. So please take note that for your sheet of HACCP implementation, you have the first sheet, which is your HACCP team members, their signature, okay, their role and expertise. The second one, which is a description of your product, your raw material, your end products, your ingredients, everything, the physical, the chemical, the biological, and the regulatory requirements limits for those products. Okay, and then you also, for the third sheet as well, you describe the intended use. I said you have the vulnerable ones, the younger people, the older people, the pregnant people, and the immunocompromised person. Then your fourth sheet should be your flow diagram. Like I said, make sure you number your flow, number your processes, the steps, and please. It's more like you're just going to do a sketch, okay? The step here says construct a flow diagram. You are going to construct your team, HACCP team. You're going to sit down together and do what? The construction of your flow diagram. You can construct for a single product or a particular product in sequential manner as in the process flow. That means your process flow should be reflected in your flow diagram. You mention the key processing parameters where necessary. Oh, for your raw material receiving to end product. Example, for pasteurization, the temperature for pasteurization to 80 to 85, it should also be stated in your flow diagram. The essence of your flow diagram is to make it as simple as possible. So an external person and an auditor or a regulatory body could also look at it and have an overview of what you are doing. I mean, it's also a good practice. You indicate entry of raw materials, the ingredients, the processing aids, the packaging materials, utilities, intermediates. Okay, your processing aids, like I said, what we use here to process one of our processing aids would be our bleaching aids. Okay, it's at the point your processing aid is entering your flow, you can as well note it there. If you have any stage of rework, also indicate it in your flow diagram. Any stage at all, it's intermediaries. Oh, cooling, weight, holding temperature, this, they are all expected to be in that loop. Add your reworking, recycling loop, in-process holding steps, any profile timer, or even as source processes, you need to add them in your flow diagram. So the next one is on-site confirmation. On-site confirmation, initially when your HACCP team had, you have sketched a flow diagram, you've constructed a flow diagram, okay? You have constructed the flow diagram, and then you need to do an on-site confirmation. Most times, what you write in paper, what you have done in paper could not really tally with the actual. So best practice is to walk around the factory again, okay? When actual running is happening, actual running operation, you engage in the shop floor, you ask questions to compare what your team, the HACCP team, has done on paper, if it's really what it is. It needs to be done by the HACCP team. It is not what, a QA person, go, you can go and do it for us on our behalf. No, the HACCP team must be involved, because when it comes to a food equipment that needs engineering understanding or engineering to explain better, and then you have a HACCP team, then you don't have an engineer in your midst. That means you wouldn't be able to understand or really put your flow diagram in the correct format. So all processes and products should be covered against what is written on the paper. When deviations are noted, they should be updated immediately. When you note deviation, when we were constructing the flow diagram, it was not there. This was not there. This stage, I've once seen a factory. I've seen a flow diagram. What was in the flow diagram? The constructed one was around a temperature of 60 to 65. Okay, cooling temperature, and then the actual is like 40 to 45. So you see, when you do a work and you look at your system, actual system, go to your SCADA, understand the parameters that are being used while running. You can as well note the deviations, and then you put them in your flow diagram. I've also seen a factory where its step was also this, and then you do so doing audits, doing food safety audits. These things they do, they come up. What is expected of a flow diagram is that everything in your process should be in your flow diagram. So, as a team members, you're supposed to sign on the flow diagram and date it. Why are you going to date it? Because for food safety management system, we are expected to maintain a certain document. Well, here the difference is that maintaining documents is like they are living documents. They are documents that you are expected to update, to also review from time to time. So we do not just you can only retain records. Your records, example, like you have done a test, an end product test. Okay, is your record. You're not going to alter the records, right? So you call those ones retain the documents. But for documents such as HACCP, plans, your flow diagram, they are what living documents. They are supposed to be maintained according to your risk. Excuse me. So afterwards, a verification is to be done periodically. So here, at this point, you also determine when and how often you verify this flow diagram. It could be yearly. It could be when there is a change in your process. I mean, when you have new maybe new suppliers. Okay, you should also review your flow. When there is a change in customers' requirements. Okay, this should also be reviewed. So your flow diagram is for a living document, and whenever you verify or you review your flow diagram, okay, always remember to date and verify. Okay, put the verification date and have your HACCP team members sign off. So before we continue, I would like us to do a little exercise. I'd like us to do it's on the screen. So are we ready? Okay. So before the next step, it's always good to have good knowledge of your process environments, and products is the foundation of what? Hazard analysis. You know, most times the people say, HACCP is product based. Yes, it's product based. Notwithstanding, you should also understand your processing environment. I would give an example. Example could be you have a plant that you have a limited space. Okay, there are no segregation. I mean, your warehouse, your storage facilities, your production, everything is in the same hall. Okay, your hazards there could be much more than the other steps where you do not the other steps that have good segregation. I will explain again. So for your company, you have a space that is too small, unlike the big companies. Okay, you have your raw material storage there in the hall. You also have your production inside the same hall, and then you also have your warehouse, the finished product inside the same hall. So you need to understand that your process environment is a high risk one already. And then you see most people, when you have such kind of settings, okay, they do not even identify pest infestation as a hazard. They do not identify it as a hazard, because if you have such setting, of course, you should also be looking at a microbial hazard, which could be what? Pests that are peculiar to the food products. For example, if you have your rice, you could have your weevils, okay, instead as part of your biological hazard. So for you to have a good knowledge of your process, it helps. It helps. So for us to even go to the principles, okay, of HACCP, you should also have a good knowledge of your process, your environment. You ensure that hazards are correctly identified. Like I've also given as an example of a space that is not that big. You should also take note of the hazard that could occur in such place. You should have it requires a deep understanding. Ensures hazards are prevented rather than discovered too late. You prevent them rather than discovering what too late. Because most times we have our HACCP, beautiful HACCP on paper, and then a recall happens. That means your HACCP is not adequate. So if you have a deep HACCP, a well thought out planned HACCP plan, okay, you should not have a recall. Okay, there should not be any recall, or there should not even be waste. So regulators, example, Food, Drug and Administration, code there is now that sports customers, they expect food safety to be built into your process and environment, not just tested at the end. You can't control what you don't understand. You cannot control it. So this is where I always say, do not copy and paste. Don't copy a hazard that is in my own organization and then replicate in your own. You need to understand what happens around your food industry. Okay, are you in a place? Do you have a lot of beds in your facility? Okay, what is the source of water? You need to understand these things before you do what, identify what hazard or appropriate hazards. Sorry. So the principles of what HACCP. Remember, after we took a break and did the test, we learned of the first 5 steps of HACCP implementation. And I also told us that we have 12 steps. And the first 5 steps, which you have done, from the 6th step to the 12th step, we have the principles of HACCP, which you can, which are principle 1 to 7. So the first principle of HACCP, when you must have done the preliminary steps rather, when you must have consulted your team, you've identified you've described your products, you've identified the intended use, you've constructed your flow diagram, and then you've also confirmed verified the flow diagram. You should now start with what we call the HACCP study proper. So you conduct a HACCP. I used to tell people, knowing the HACCP analysis is the key element of HACCP. It is the key element of HACCP. So it's always advised we not throw we do not err on the side of caution when it comes to hazard analysis, because the resulting food safety plan is dependent on your hazard analysis. If you don't know how to analyze your hazards, if you do not identify them, okay, if you do not analyze well, I mean, the whole essence of the HACCP plan is futile. Okay, so this step is very critical. That you should have your HACCP team come together. People will come to give suggestions. You throw questions. You understand. You make research with scientific articles. You consult food safety consultants. You consult food scientists and technologists. For those of us that are not specialized in that field, so you will be able to understand your hazard, remember, associated with your food and your work process. So you identify all potential hazards, like in the beginning of the class, I mentioned the physical, the chemical, the biological. So you identify them. The physical, it could be the nail, it could be the jewelries of the staff. At what point can they be controlled? At the evaluation of them, so that they will not cause adverse or health effects to the consumers. So tips on identifying hazards for your food. Like I said, some food, there are hazards that are inherent or naturally present in your food. It could be your raw materials and your product contact materials, your processing aids, your packaging materials, finished product. Examples could be your toxins, your heavy metals. Once you have a good knowledge of the nature of your food and the hazards that could be inherent or naturally occurring in them, you'll be able to identify them. And that tip is also to hazards that are likely to get introduced at respective steps. It could be through your lubricants from their machines, okay? Like I said also, from the hair and nails for personnel. After maintenance, the nuts and bolts, they could be introduced in the process. So when you're able to identify them, from this step now, during sorting, okay, you have a pineapple as your raw material, and you know that already from the farm, you have the husk, you have the stand, the stones, they will follow the raw material from the farm. So you already know that you have a physical hazard, which is the stones. The stones are there, the sands are there. you know that already, and that's the one alone will now give you the knowledge, okay, to how to analyze your hazards. So you develop a hazard analysis worksheet. Remember, I told us you can build in an Excel sheet where you have sheet 1, sheet 2, sheet 3, sheet 4, sheet 5. Okay, so the sheets now we can have what we call sheet 6, depending on how you are placing your sheets. Okay, because some persons, when it comes to your raw materials, okay, people can create multiple sheets because they want to treat each raw material or each product contact differently. So any way you want to do it, this another sheet, you have your hazard analysis worksheet, proper hazard analysis worksheet. In this worksheet, you are going to be developing a kind of table, okay, where you even assign risk, okay, and hazards, and then you do a risk assessment. It could be the risk assessment could be I always suggest people just do your two-way risk assessment, your likelihood and the severity of the risk of hazard occurring. So that way, it's always what simple. Keep it what simple. Use the probability of a risk of hazard occurring, probability of sand being in your raw material, and the severity of this sand if controls are not what in place. That is an example of what you do with your hazard analysis. If you do not have controls, as in like the probability and the severity of it happening, okay, and then you put what controls in place to make sure that it do not what cause adverse health effects. So remember, maybe I would also share what a hazard analysis worksheet looks like. Maybe for people that are interested after the class, you have to also justify your claims. For you to say that, oh, probably that sand over time in your process could cause this, you have to justify. It needs to be justified, and justify your claims is not what you just come up on your own. You come up with, okay, you have your codes, like I shared with you. You can always cite the reference depending on the regulatory standard you are working with. Hey, let me explain this. So for your food business, in particular now, you are using codes guideline. Codes guideline. It is mandatory that you do use regulatory limits that are what embedded in what the guideline. If you are using maybe a guideline from your customer, well, if you can just if your customer has a good justification, you can also what come in. If you are using a guideline from the NAFDAC, you can also use it to justify your claims. Your PRPs, they manage insignificant risk. I would explain what significant and insignificant means in terms of what food safety. So your PRP manage the insignificant risk, while the OPRP and CCPs, they manage significant risk, which are good in the HACCP plan. These are all going to come inside your worksheet. So see how the worksheet works. You have your flow diagram, right? The flow diagram that you are able to list out the steps, the interaction in your process. So for you to do your hazard analysis, you pick them one after the other. But that's first. That is why I said you need to what? You need to number. You need to number your steps in your flow diagram. You get step number 1. You replicate it inside your hazard analysis worksheet. What are the hazards that will occur in step number 1? If they are physical hazard, you list them. The chemical hazard, you list them. Biological hazard, you list them. And be careful not to use generic. Like people say, oh, for physical hazard, they say foreign materials. What are foreign materials? The foreign materials that might be in my process might not be in another person's process. You understand me? So you need to understand your process and your products. So list out the physical, the chemical, the biological. You can choose to have a different column for allergenic, but like I told you, some persons might group allergens into their chemical hazards. So for each step that you have made on your flowchart, okay, you replicate each step. Remember the number 1 on your flowchart should be number 1 on your worksheet, and then you do the hazard analysis. What is for each of them? For your physical hazard, what is the probability of it happening, and what could be the severity? Don't worry, the next slide we will understand better. So after you have assigned a risk for it, probably if it's a significant risk, okay, you will now go to what we call decision tree. We'll get there. But for insignificant risks that are not significant, they cannot cause immediate food safety harm. It cannot cause hazard immediately. They are what we can classify them as insignificant risks. And this insignificant risk is just a general terminology. Your risk assessment should be able to justify this as well. Your risk assessment should be able to do or justify this. So what hazard analysis is all about is it's a process of you identify, you gather, you interpret, you evaluate hazard associated with the food in all steps. In all steps, remember the steps in your flow diagram. Each of the steps you bring into your hazard analysis or a worksheet. You list out the physical, the chemical, the biological, and then you assign risk rating based on the probability and the severity of them happening. And then you put control measures. And then after the control measures, you also have a justification. If it's going to be a PRB, you justify it there. So let's continue. So, like I said, what is a significant food safety hazard? According to ISO 22018, you have significant food hazard. There are food safety hazards identified through the hazard assessment. Remember, I told you it must be justified through the word hazard assessment, which needs to be controlled by a control measure. That is what ISO 2018 has mentioned. So this significant hazard, according to Codex as well, is a hazard identified by a hazard analysis as reasonably likely to occur at an unacceptable level in the absence of control, and for which control is essential given that's the type of error, given the intended use of the product. So reasonably likely to occur at an unacceptable level in the absence of control. Like if you have some certain high risk food, if you are into meat processing, you already know that the high risk food is staph aureus there of salmonella, okay, and already there's a hazard there. The hazard analysis for you is significant already, because if you do not address it, if you let it go, it's going to cause harm, if not death, for the consumer of the food. Excuse me. Okay, so this is what a risk assessment looks like. What is risk assessment? Like I said earlier, just do a two-way risk assessment. Don't get it or don't just get it clumsy. Because people might choose to do a two-way assessment, but for sake of HACCP, it's always advisable to use a two-way risk assessment. What I shared with you here is a typical example of the risk assessment I work with. And this is the simplest of them all. You can always read up on your own to understand. So risk assessment is a structured, science-based process used to evaluate potential hazard in food risk by examining the likelihood. Remember, I said the likelihood of this thing happening and the severity of adverse health effects. So most times, people, the problem is always about the likelihood. You know the severity as well. People get to understand that one immediately. If we have needle in the food product, one person ingests it, it's going to cause harm or death. So you understand the severity, right? The likelihood now is a bit technical, okay? Most people, depending on your process as well, of this thing what happened. So the table here, I have a five score, okay, 5 score for my likelihood and a 5 score for the severity. For the one could be, it will occur once in every 2 years. Once in every 2 years, if you're studying your process, that this is rare. When you say a risk or a risk is rare, okay, it's likely to happen once in every 2 years. When you say it's unlikely to happen, it's unlikely. It will occur once every 1 to 2 years. So the possibility, it's possible that it will happen. It will occur once every 6 to 12 months. So you can always use this as a guide. Almost certain. If it will occur on a monthly basis, it is inherent in the product. It is inherent in the process. It will always occur. Okay. So the severity. When you say it's insignificant, it has minor effects. The presence of the hazard does not and will not result in unsafe food. There is no injury, illness, or hospitalization if the hazard is consumed. If the hazard is consumed, if the customer takes this, it will not cause harm to the consumer. So it is insignificant. It is what? Insignificant. So another one is what? Low. Low could be that the presence of the hazard can cause inconvenience and minor injuries or illness that require first aid only. So most times here at food level, if you take okay, sorry, in drugs, if you take inappropriate dose, see what you this is the doctor and the lives to be your first aid. You understand? So another one is what? Medium. Injury or intolerance. Okay, it can cause injury or intolerance, not usually life threatening. Consumers do not suffer any long-term effects and do not require hospitalization, although acute medical treatment may what occur. The presence of the high ones is that the presence of the hazard will cause hospitalization of those affected. Prolonged medical treatment will be required. Total impacted one person or more, but less than 10. Extreme is life-threatening or long-term chronic illnesses, infection, intoxication, anaphylaxis in the case of your allergens, the chronic effect or death. So you already know this one would guide you to know the likelihood and the severity. I was screaming on the screen. So this will guide you. And then when you have a good understanding on how to score your likelihood and severity, you develop your matrix. The matrix is always multiplication of your likelihood and your severity. So for instance, here, if you have a hazard that is rare to occur, that might occur once in every 2 years, you know that it's what the score is what 1 already. It's insignificant. And then if the severity is what if the severity is high, if the severity is high, you have, for instance, 1 times 4. 1 times 4 is also what? Insignificant, because it's rare and the severity is high, and because it's rare is what is significant. So this table here can always help us to guide us on how to develop a proper risk assessment and then assign scorings. So my table here, like I told you, is what I work with. You have a non-significant, they are controlled by what? PROPs. So those ones that will not cause immediate safety harm, they are the what's not significant. Remember, in your worksheets, that is where you put these things. The first step, you have identified, you can assign your risk score. Okay, the probability of it occurring is rare, that is 1, and the severity it could be low, which is 2. 1 times 2 is what? 2. Okay, so that way you assign it as a non-significant. It's non-significant and it can be controlled by what? A PRP. So for your risks that are high, already you know from your matrix. And like I said, you can use this matrix. It can help. It's standard. Okay. For the significant risk, they will go through what we call what? A decision tree. They'll have to go through a decision tree. I will explain in the next slide. Your significant risk goes through a decision tree. So the decision tree is it helps to assign proper control measures for identified significant food safety hazard. And the decision is always guided by your regulatory requirements. Like I said, if you are subscribed to ISO 22000 2018 in your facility, you might choose to use the codex, because it's also allowed. Codex decision tree is also allowed for the decision tree, okay, for risk of significant hazards. So you can also use the one of FSS 22000 decision tree. Now I shared earlier, part of the material I shared with Madam Immaculate, and I'm sure she also shared with us, that is a decision tree that can help you to decide if this is what a significant risk, and also put appropriate control measures in place to make sure that they do not your food does not go to the consumer unsafe. So here below here is the table of blue is a type of hazard analysis worksheets. Okay, and please also remember that you are supposed to put the acceptable level of hazard in the end product. So what is the minimum CFU in your product, okay, only for forming units, you should also what put it for your microbial what hazards. It's the best practice to do. So the next step is, like remember I told us, once you have conducted hazard analysis and you now have determined your insignificant risk, for you to as well determine your critical control points, you should also use what we call a decision tree. A decision tree will help you to determine the control for the significant risk. Your decision trees will also help to determine the action criteria for your OPRPs. So basically, when we see HACCP, 7 principles of HACCP, you see determine critical control points alone. Fine. For food businesses that do not have OPRPs, I would explain, you can always limit it that towards your critical control points. But for food businesses that have a PRP, you can always determine it at the 7th step, which is the second principle of hazard analysis. So the operational prerequisite program, what are they? Like I said, I will explain, is the control measure or combination of control measures applied to prevent or reduce a significant food safety hazard to an acceptable level, and where action criteria and measurement or observation enable effective control of the process or the product. So it is just like you have also we say significant risk. It could be your CCP and for OPRP. So for OPRPs, operational prerequisite program, they are not that stringent like your critical control points. Critical control points is the point that of food, which I actually start my class, is the last point of food safety defense. At that point, if you leave the product, it goes to the consumer, and you know what happens. It's either the consumer gets injured or the person falls sick or die in the process. So, for operational prerequisite program, they address or reduce significant food safety risk, fine, but it does not automatically mean the product is unsafe. It does not automatically, because it's a kind of observation or measurable in real time. You can put the process in check. Example is you are supposed to sieve or filter. Okay, you are filtering. You are supposed to observe the filtered product to check if the presence of impurities they have been filtered. Remember, it will not automatically result to unsafe food. It doesn't, because you probably in the long run you have a CCP, which is at the last point that will address this. Because once it gets to CCP and nothing is done, that means your product is unsafe. So critical control points is also a step in the process at which the control measure is applied to prevent or reduce a significant food safety hazard to an acceptable level and define critical limits and measurements. So take note, for the OPRP, you have what we call the action criteria, and why for the CCP, you have the critical limits. So the OPRP is, do something. You have to do something. You have observed this, observable, and your measurement is out of control. It's not within the measurement. Do something to bring back the process in check. But for critical control points, look at the critical limits. So figure out which steps are critical for food safety. Always the last point for food safety defense, like I said, a control here is essential to eliminate or reduce the food safety hazard to a safe level. If not identified, the hazard associated with the food causes harm or adverse health effects to the consumer. So example of CCP is cooking chicken to kill salmonella, pasteurizing ready-to-eat food, example margarine, yogurt, etc., to eliminate pathogenic microorganisms. This is where the CCP decision tree comes in. Decision tree, I've told you, we have the COSET decision tree, which is the traditional decision tree, and we also have the FSS 2000 decision tree. You also have decision tree probably from your customers. But the goal is know how to justify your decision. So for me, because I have a process that requires me considering a professional prerequisite program, example I gave is saving. I decided to use the FSS 2000 decision tree. Because in the past, when this decision tree came out, the feedback from the GFSI is that it's complex. People don't get to understand it. But I think the recent publisher of this decision tree that came, was it May this year, is quite simple enough to help us, guide us, make that decision to understand if we can assign an OPRP or a CCP. So differences between PRPs, OPRPs, and CCPs. What are the differences? The differences, like I said earlier, PRPs are more like your GMPs, okay? All those programs that focus on hygiene status of the production environment, your facility, your program, the people. The hazard that are generic, failure may occur without immediate impact on what food safety. Failure may occur, but it will not have an immediate impact on food safety. So OPRP is focused on the prevention of hazard, cross-contamination or proliferation of foods during production. Failure doesn't automatically, I said it before, mean a product is unsafe. Action criteria for OPRP shall be measurable or observable in real time. It must go through a decision tree. So after you must have conducted your hazard analysis, you determine a critical control point and also an OPRP. Those two things, they fall into place because they are significant risk. They are going to be addressing a significant risk. So the CCP focus on products, process, raw material, in some cases, and focus to eliminate and prevent and reduce significant hazard to an acceptable limit. So failure means that the product is unsafe. Critical limits at CCP shall be measurable, must go through a decision tree, must be the last point of the safety defense. Failure in a CCP or OPRP will result in likelihood that product may contain, in high likelihood that product may contain a food safety hazard. So here we have the decision trees. We have the FSS 2000 decision tree that was published in May 2025 and the codex that was revised 2022. So this decision tree will help you after you have identified a significant risk. So for that of the codex, it says, can the significant hazard be controlled at an acceptable level at this step by prerequisite program? So if the hazard, even if it's significant, okay, and can be controlled by an acceptable level, I will give you an instance of probably in the past you had it as an OPRP, and maybe history of your process. You now find out that the controls you have, which are the prerequisite program, they are helpful enough. They are helpful enough. There's not been any need to keep calling this an OPRP or a CCP. So if the PRPs, example, your cleaning, your pest management, if they can control this significant hazard at this step, that means it is not what a PRP. It is not a CCP. Sorry. If that is the first question, if it's yes, it is not a CCP. So, but if it's no, do a specific control measure for the identified significant hazard exists at this step. You do a specific control measure. Your hazard team again will have to put control measures in place. We need to put this metal detector here, or we need to use this magnets to capture the capture the metals in the process. So if there is no step, if there is no control measure in place at this step, it is also not a CCP. But if there is a control measure in place, you will not go to if you do not go to the third question, which will a subsequent step prevent or eliminate the identified significant hazard. So if there's a subsequent step that will eliminate it, that step is what? A CCP. So usually when you ask this question to the third question, you now know that you have a CCP already. The third question, if you have a yes and you have if you have a yes and you have a no. No, if you have a no first and you have a no again, and then you have a yes. You have a no first and you have a no again and you have a yes, it is not what? A CCP. So for CCP, of course, that's decision tree. It's a straightforward decision tree. And particularly for food businesses that has only CCPs. But if you have operational prerequisite programs, okay, an example I have given to us, your CV, okay, you might not need to use this codex decision tree. You might need to use the FSS 2000 decision tree. The FSS 2000 Decision 3 gave a room for OPRP. You can always read it up on your own to enable you assign where appropriate OPRP, and then it also give tolerance for CCP. So basically, right now I use FSS 2000 Decision 3. It helps to assign OPRP in my process and then CCP at the same time. So after you have assigned your OPRPs and your CCP, like I said, which is the second principle in hazard implementation. You remember the first one is conduct your hazard analysis. Second one, determine critical control points and your OPRPs. You also need to do what? Establish critical limits. You establish critical what? Limits. Critical limits for CCPs and also action criteria for OPRPs. So critical limits is measurable value which separates acceptability from unacceptability. The acceptability from what? Unacceptability. Critical limits, they define boundaries between safe and potentially unsafe food. For action criteria, they are measurable, observable specification for the monitoring of an OPRP. It is vital that they are set at correct level for each criteria. Deep understanding or deep knowledge on the control measure, hazard, product, and process is needed to define robust limits criteria by the HACCP team. You should have a deep understanding and of your process, of your hazard, for you to establish a control. If it's going to be an OPRP or it's going to be a CCP. I have already given us the hint. CCP is always the last point of food safety defense. Once it means, it's more like you're in a beach, okay? And the defense is playing this game. I usually tell my class that the defense person might be the OPRP, okay? While the midfielders, the other team players, they are the PRPs. And then your goalkeeper is your CCP. Once the ball leaves the hand of your goalkeeper, it results to an unsafe food. And as well, OPRP is also critical, more like a defense. Because if the defense is also not strong enough, it could also result to an unsafe, but not automatically. So for OPRP, sorry. So for OPRP and the CCP, the rationale behind these things should be recorded. It must be documented. Everything you'll be doing must be documented. So if you are using the codex, please reference it that you are using the codex decision 3 for your CCP determination. But if you are using FSS 2000 decision 3, also be documented. You set minimum or maximum value that must be met at CCP for it to be safe. Again, another reference material could be that, that at a certain temperature of this, or maybe something at 75 degrees for 15 seconds during cooking, pathogenic microorganisms are killed. So you're not just saying it, you are going to be providing a proof and evidence, maybe a study that would show a reference document, or according to this document, you cite it, or according to NAFDAC rules and guidelines, according to your NIS standards, what is the limit? What is the limit for this particular parameter? What is the limit for your pasteurization in your yogurt factory? What is your limit for cooking in your factory? So these are the things that you should really document and also record. And like I said, you can always cite articles. You can also always use maybe your NIS, which you are subscribed to for your organization. You can also use codex. You can also use FSS 2000 document, which is comprising of ISO 2000. So for you the thing is just for you to be able to justify with scientific data. So for your OPRPs and your CCPs, remember the action criteria and the critical limits you need to support with the scientific data. It shall be probably from research work, which has been endorsed, from the FAO, anything that is authentic, that will make your study gain relevance. This is what is expected. So next step, I would want to share with us an example of the critical limits. Most times we have arguments when people say, This is critical limit. The critical limit must have an upper and the lower limit, not for all critical limits. So types of critical limits. It might have a lower limit, another one upper limit, another one will be in range, which is upper and lower values, as described on my slide. For the lower limits, an example is your cooking temperature at 75 degrees centigrade for 15 seconds to destroy pathogenic microorganisms like salmonella. So your lower limit is that this is the lowest you can go. That is for your process. It is the lowest you can go. And remember, for when you're talking about limits, critical limits, you are looking at your CCPs. Please don't forget, when you see a critical limit or critical limit, yes, you know that it's what CCP. And for the lower limit, like I've given us an example here, it's the lowest. You cannot go below 75 degrees centigrade for 15 seconds. That is, if it is what it is in your critical limit, it must be adhered to. It must be adhered to, and it must be validated. Most times when we establish critical control points and OPROPs, we fail to validate it. Validation means that you want to prove that this will work. You want to do what? It's a proof that a plan will work, and it's always before implementation. So your HACCP study, you have done your hazard analysis, you have identified your critical control points and your OPROP, and then for you to establish the critical limits for your CCP and the action criteria for your process as well, you have to validate it. You have to check, subject it. For instance, again, if you are using a metal detector, okay, as your CCP, as your last point of food safety defense, to the products will go through it, you have to validate that this metal detector will work. And what will always help you is what some scientific data, and also from OEM, like the producers of that machine. You can read up the article and then you subject it. You might try to do a vibration test for that metal detector to see if you have a vibration in your system, will it work? You understand? So you subject it to the worst condition to make sure that your controls, which is maybe your CCP as a metal detector, or your OPROP for saving, it can work. So the lower example of lower limit I've told us here is what? Critical cooking temperature, and which is not going below 75 degrees centigrade. And the pH of the product also, not going below 4.2 to prevent growth of Clostridium botulinum, depending on your product. So if you don't need to, this is just the minimum value, you will not go. Because once you go below it, and probably if it's not what is required by your regulatory body, if it's not what is in your NIS or for your NAFTA guidelines, and then you know what that is, there's likelihood that it's going to cause harm to the consumer. So it's more like your safe control, your tight control. You don't go below it. And for critical limits that have upper limits, so it will be in form of the pesticide residue, not above 0.05 parts per million, okay, to avoid toxic chemicals. Metal detector setting not above a capturing of 2.0 ferrous to prevent physical hazard in the finished product. So these are examples of where you have a lower limit for your CCP and an upper limit. So the last one is the range. That's why we have the both upper and the lower limits. The pasteurization of your milk, okay, at 72 degrees centigrade to 75 degrees centigrade to ensure sufficient heat to destroy pathogens for 15 to 20 seconds. So you must be within that upper limit and the lower limits. So you might not need to exceed the upper limits. Some persons exceeding the upper limit might lead to poor quality of the product. So these are examples of critical limits for your CCPs. An example of the OPROP action criterion example is for in juice production, for people washing of your fruits and salting. Okay, the hazard there could be your pesticide residues, physical contaminants, stones, twigs, spoiled fruit. OPROP could be washing fruits with potable water, sometimes with sanitizer like chlorine. So action criterion is to maintain sanitizer concentration in target range and change wash water every hour, as you described. So why is an OPROP not CCP? Washing reduces hazard but does not eliminate all risk. Pasteurization is the CCP. So pasteurization is the last point of the defense. Even after washing, okay, it might not eliminate all the risk, but your CCP, which is the last point of food safety defense, it should be able to eliminate all your risk. So as of filtration as well is also an example of action criteria, and then equipment hygiene. You can always read it for your time's sake. So after you must have validated, remember I said you have to validate to prove it's actually working, your critical limits and your action criteria for your OPRPs, okay, and for your CCPs. You establish a monitoring system. The HACCP team will have to establish what? A monitoring system. Who is responsible? Who is responsible for monitoring your OPRP and your CCP? How? What will be monitored? Is it the washing, okay, receiving for OPRP? Is it what will be monitored? Is it the level of the chlorine for your monitoring? Where will it be monitoring? Why will it be monitored? Is it at OPRP? Oh, for the initial slide I shared, your chlorine residue in washing of your fruits, okay? And then where is for your OPRP, right? Okay, and then how will it be monitored? How do you monitor it? It's how many parts per million is expected to be there, okay, of residual chlorine. So, and what is the frequency? How many? What hours? Is it after each wash or after the 20 washes? Okay. So you need to understand. You need to define this as well. And who is responsible? You have to assign responsibilities for your monitoring. Somebody will need to monitor this. Most times here we say, okay, the process owners or probably the production operators, okay, you monitor and then you real-time record it. So what is monitoring? Monitoring is determining the status of a system, a process or activity in ISO 2018. It's conducted at planned a sequence of measurement and or observation of control parameters to assess whether a CCP or OPRP is under control. So monitoring is more like, monitoring is more like checking if something is being done according to the plan. Okay, sorry, but that is validation. Validation is trying to determine if something will work according to its plan. While monitoring is the art of doing something according to the plan. Art of doing something according to the plan, like according to your validation, according to the validation report that you have to monitor. You have to check this time, this that. That is what your monitoring is all about. It's always what real time. So validation is less often. Validation is less frequent, okay, while your monitoring is what more frequent. It is what you do consistent, like is necessary. You observe every time according to your defined words frequency, while verification is what less often. Validation is less frequent, monitoring is what more frequent, and verification is what less often. So I think in the next slide we'll also understand how verification comes into play. So for your HACCP plan, for your HACCP study, after you have identified your hazard and you have determined a critical control point and your OPRPs, and then you have also established or validated your critical control points or your critical limit and action criteria, okay, you need to do what? You need to monitor. It has to be monitored. And this monitoring should also be documented. It's not just about, oh, we are monitoring it. Oh, unfortunately, most times when I go for audit, when I want to audit, and I ask, can I see your monitoring report? Oh, we have it there. We have shift A, they monitor it at a certain time. And then once the evidence of monitoring is not there. So for your HACCP system to be functional, you need to understand the difference between validation, monitoring, and what? Verification. So that way you'll be able to understand how to control your hazard. So the next one is establishing corrective action. Basics of you are trying to be you are trying to be proactive you are trying to establish corrective actions in case something goes wrong. Okay, so we don't wait for things to go wrong before we do what we foresaw it. So according to FSS 22000 or according to ISO 22000 2018, the action to eliminate a detected non-conformity. One, you have to let it down, write it down, let it be documented. What correction should be taken when your critical limit is what breached, or when your OPRP is what breached. What is the immediate correction that will be taken to ensure that you bring back the product in good condition or in safe condition? So this stage is talking about. So there are two things, mind you, because most times people will go ahead to mention their corrective actions as corrections. Correction, like I said, is that immediate action you will take to eliminate a detected non-conformity in your maybe in your action criterion or in your critical limits. It is that correction. Oh, at that point, there's a breach of the critical limits. The product was not pasteurized at so temperature as according to your established critical limits. And then the corrective action in place is to do what? You get back the product to that temperature by maybe pasteurizing again to your set critical limit. That is what correction. But for your corrective action, here you eliminate the cause of this non-conformity. The cause could be the monitor, the person that is monitoring, or the person that is recording doesn't know what to do. The production operator doesn't know the right critical limits. And then what do you do? How do you put a corrective action to prevent this deviation from not occurring next time? Action to be taken when results or CCP or monitoring indicate loss of control. You put that corrective action to make it not to happen again. If your production operator doesn't know the right critical limits for your CCP, okay, you need to do what? You need to train. You need to retrain your production operator. And if you do not have a clear standard operating procedure at that point, it could also result to a failure. That is why HACCP plan has it that you put these corrective actions in place in case things might in case things goes out of place. I mean, there is no perfect system. But once you have your corrective action in place, things will do what? Fall into shape. Example of not acceptable corrective action. You see when a product probably there's a breach in the critical limits. It's not conforming. What is written on the monitoring record is stop production, quarantine products, contact QA. It is not acceptable. That is not a corrective action. It's not QA. QA is not a corrective action. Contacting QA is not a corrective action. You have to put in place what things that will be done. Define it. Are they supposed to send back the product to pasteurization again? Are there processing parameters that needs to be adjusted? Remember that are inherent in your process. So, like an example of my process here is that once there is for a CCP, which is a filter bag, okay, once there is a breach of that CCP, a root cause analysis will be done. What happened in the process? What we do here is that the process for some time, and then you do a kind of reactive measures. Kind of you test your product again and again to understand what really went wrong. If it means for you to if it means for us to downgrade and start reprocessing, it is always what we do as a correction. But the corrective action we now look at, the failure could have been inability to adhere to a calibration schedule. Okay, inability to adhere to calibration schedule. The pressure bar was not calibrated. Things like that. So for your system to work in place to be functional as well, you should also remember to put your corrective actions, things that you do to prevent feature non-conformity or future recurrence of product. Hello, can you hear me? Hello?
Yes, please.
Okay.
Yes, we can
So,
hear you.
okay, so the next step here now is what we call the establishment of verification. You establish a verification procedure. Like I said, your validation comes before what? Monitoring. Obtaining evidence as a control measure that your control as a CCP or OPRP will work. That it will be capable of effectively controlling the significant food safety hazard. Here, people, like I said, we have to be careful so we don't throw caution to air. Some persons will say is one of just your validation you go. It doesn't work that way. So your validation of control measures could always happen maybe yearly as well, depending on your historical data. So see what happens if you have a change in your process. You need to do what? Revalidate. You need to do what? Revalidate your control measures. Oh, you bought a different equipment. We are using this metal detector and we just changed. You need to do what? Revalidate it. You need to revalidate this new one. You have to also determine a validation frequency for your control measures. So it will be capable of effectively controlling the significant food safety hazard. Verification comes afterwards. Validation. Verification comes what? Afterwards. Validation. It comes after you must have validated. Oh, and you see that the monitoring is taking place. It can be through objective evidence. An example of your verification would be periodic auditing. You can audit your process. You can check independently. Verification is always done by someone that is independent of the monitoring. So sometimes people say, oh, because I am the one monitoring it, I will be the one to verify it. No. Remember, monitoring is you are doing something according to the plan, which is the validation. And then verification is to check if something is being done according to the plan. So take note of differences. So you have to check if it's done if it's what's happening. So you have your validation, you have the monitoring, and you have verification. So you establish a verification method again to know that all your hazards that you identified, even if they are PRPs, even if they are OPRPs and the CCP, verify if they are doing what? Working. Is it working in practice? Is the operation fully compliant to HACCP plan? If you have in your HACCP plan that you are supposed to filter with a micron size of a mesh size of 8 mm, at the end of the day, is that 8 mm sufficient enough to capture the foreign materials in your process? You need to verify, and you also need to verify the documents, the monitoring of your food, your operators or your production supervisors, whatever, whoever that is monitoring. You need to verify. That is why we do GMP audits, monthly GMP inspection, depending on the risk in your process. You need to check from time to time. You check the records, okay? From time to time, you look at the monitoring records to understand if the monitoring is being done, and also if there are needs for corrective actions. So basically, the verification is done by an independent person that is not the person that is monitoring. So the person that is monitoring your process, it is not the person to verify your process. There are two things. There are two different things. So for your HACCP plan, very good job. The HACCP team, you come together, you put everything together, and then you assign responsibilities, like I said, in the monitoring, where, how, when, what will be monitored. And then who is going to be verifying this is also need to speed up to also be established. So tips of validation is you are done before development starts. Development steps are done. Second, you repeat regularly. Repeated regularly is less frequent. Change management. So when you have a change, there's a new equipment, you have a new customer that requires that you need to validate. And then you verify, make sure operational team can do the steps required as intended. You check in compliance to procedure outlined in HACCP plan. So I'll give you an example. An example of monitoring is mesh of maybe 5 to 5, a mesh size of 8 mm, and the monitoring should be that, oh, this mesh size, is it adequate, okay, to capture? Are we getting a lot of contaminants? Is the mesh sufficient enough? Is it does it have bypass? So if somebody is monitoring, for instance, if somebody is monitoring your mesh, which is your OPRP, your OPRP, the person will be able to know when there's a gap on the mesh, right? The person will also know when there is a bypass, and the person will also note and then will do corrections and corrective actions. And then for the verification, so it's not frequent like your monitoring. It has to be less words. Yes, it has to be less often and not less frequent like the validation. So the last step in your HACCP implementation or your HACCP steps are, which is also the 7th step of hazard analysis principle, is what? Yeah, documentation information required to be controlled and maintained by an organization and the medium on which it is contained. So for ISO 2018, the clause 7 is talking about support, which the documentation is also part of. It is a requirement of the standard that you must document. Your OPRPs, your PRPs, your CCPs, whatever the case may be, they must be documented. Remember, if it is not documented, it is not done. It is, why are you going to be documenting these things? It is a proof of food safety management, a trust of your customers via our certification, your database for continuous improvement. So for us, our HACCP plan has to be a living, not one of, like you have your hazard analysis, okay, already you've done it, you have your hazard, you have your OPRP and your CCP control plan, yes, also documented. You need to have those documents, example of the HACCP team and responsibility, your flow charts, your flow diagram, your hazard analysis, all of them. You need to document all these things, and you also need to verify from time to time your CCP determination and justification, and then you have to keep your critical limit determination, justification, and the likes. So all of these are the records that you might need to show that you have a working HACCP, that you always present to your auditors where necessary. So this is the last slide. Let me test our understanding. So like we did the last time, you can always try out these 10 questions to know your understanding of this class today. And you submit to the facilitator, I mean, so let's do this. Let's see how we
Please, Kehinde, can you mute yourself? Nathaniel, can you mute yourself, please? Nathaniel, can you mute yourself? Can you mute your mic? Thank you. So just like we did the previous one, we have some sets of questions on the screen. So just provide the answers to the objectives on the chat box so that we read out to our faculty. We're almost concluding.
So, basically, we have ended this class now. Okay, this is the first, or what we call the preliminary mastering HACCP class for beginners. And I'm sure that we are able to understand what hazard analysis and critical control point is, and where necessary, how to conduct hazard analysis. Okay, and then remember that you always need to have your decision tree that will guide you properly assigning whether it's OPRP or CCP, and also know that for your OPRP, the best decision tree for you to use would be your FSSC 22000, or I don't know if you have a requirement from your customer that might for you to do that, depending on your process. Okay, and also for your CCP, it can be your codes, the codes, the short tree. In that material I shared with us yesterday or so, we have the decision tree for the codes there at the same time. So those because it can also help you to get ISO 22018 standards to help you understand the concept of hazard analysis. I think it was 8, which is operation. It talks about how to identify hazards and how to assign risk, okay, for OPRPs or CCP and the PRPs. So these are basically what we are expected to do. Like I told us, this is just a beginner's class for HACCP implementation. You might need to want to do or go for an advanced class. You might need to go for an advanced class for HACCP implementation. So like I said, it doesn't stop here. You have to take an action. We can always come for advanced class. So thank you everyone for your time today. Any question? What